So here's a quick review on the distributive property. So if we remember, the distributive property is where we have a number outside of our parentheses that's both being multiplied to everything in the parentheses. So often in class, I say multiply A to B, A to C, so that we have A times B plus A times C. But I know that sometimes when I do this, we make mistakes. We forget to multiply the A to the C, or we make mistakes with the signs of our numbers. So an easier way to think about this is thinking about this as an area model, where we're multiplying length times width of a rectangle. So how does this relate to our expression? Well, let's look at this example, -3 times the quantity x plus 1. Let's make the number that's always outside of our parentheses represent the length of our rectangle, and the inside of the parentheses represents our width. So when I plug this in to my rectangle or my area model, again, we said that the length is -3 and the width is going to be x plus 1. Now, since I have two terms down at the bottom, I'm going to divide now my rectangle into two smaller rectangles. And then I'm going to find the area of each of these smaller rectangles. So this first rectangle has the length of -3 and the width of x. So we end up, when we multiply those together, -3 times x. Then we're going to repeat the process for the second square. Again, the length of it is -3 and the width is 1. So we're going to do -3 times 1 to give us a -3. To then get the area of this rectangle, we will do -3. We'll add them together to get -3 minus 3. Now we can't add them together because one of them has an x and the other one does not. So that means they are not like terms. So this, sorry about that, is our final answer, -3x minus 3. So I'm going to give you a few more examples to try on your own. And so what I'm going to do is that once I give you these 3 examples, pause the video, attempt them, and then hit play again to see if your answers compare to mine. So our first one will be -2x minus 1. Our next example will be 3 times -x plus 6. And our last example will be negative, this is a tricky one, x minus 1. So pause the video, attempt these problems using your area model. So now that you've done these problems, let's use our area model to check your work. So here I have -2 as my length and 2x minus 1 as my width. I'm going to find the area of each of the smaller squares. So this is -2 by 2x, which gives me -4x. This is -2 by -1, which gives me 2. So my area of this squared is -4x plus 2. I'm going to repeat the process now for the next one. Sorry for my bad squares. So 3 times -x, remember there's that ghost one there. That gives us -3x because the length is 3. This is -1. Our next square, the length again is 3. This is 6, so it's 18. Add those together and our area is -3x plus 18. And then for our last example, again, we have this negative on the outside. So that meant that there's a ghost 1. So I'm going to write my ghost 1 and x minus 1. I'm going to find the area of my smaller square, so -1 is the length, and the width is x, so that gives me negative 1x. On my next smaller square again, the length is still negative 1, and the width is negative 1, so negative 1 times negative 1 is positive 1. And so add those together, and there is the area of my rectangle. And so now you've just done the distributive property.